EPIC is the European Photonic Industry Consortium. European-oriented, but not European-exclusive. Technology has no borders. One of our members is Santec. Santec is not a European company, but it's a company enabling the European industry do inline testing. When it comes to production, testing is key. That's why we are here today with Santec. We're going to hear a bit more about the testing capabilities of Santec. Could you tell us your story?
Yeah. So originally Santec was working for telecommunication application, but we extended the technology to medical and industrial test field, like inline inspection. So today we are showing the OCT technology. This is a cross-section image modality. It's originally suitable for medical application like ophthalmology and cardiology. But we extended also this technology to industrial application, inline inspection. For example, the silicon wafer devices and the plastic mold devices and liquid crystal display like a touch panel. They are using our OCT technology for inline inspection. So this OCT technology is suitable to show the cross-section image of the sample. You can see the inside of the material with a higher resolution, better than the X-ray and the MRI. Of course, we have some limitation of the depth, but if it's a suitable application, OCT has a very powerful tool to get information. Today, this show, LASYS, is one of the major topic of LASYS is laser welding. So we show that some application of the laser welding using OCT technology. So of course, we cannot see the inside of the metal because of the light cannot penetrate in the metal. But we can see the surface even if there is spark or smoke from the material because we are using coherent technology. So we have a very high sensitivity to measure the material. So for example, you can see the keyhole during the laser welding, and also you can get the profile of the keyhole using this technology. Actually, already the OCT is installed to laser welding application, but the technology was the conventional one, spectral domain OCT, based on the low coherence LASYS and the CCD camera spectrometer. So we are showing SSOCT, swept-source OCT. This is advanced technology of OCT. For example, now in the medical market, spectral domain OCT appeared 15 years ago, but now almost them are using SSOCT because of the advantage of the performances. For example, the sensitivity is higher, 4 times higher than spectral domain OCT, and the resolution and the imaging depth is completely better than spectral domain OCT. Of course, SSOCT is a little bit complicated than the spectral domain OCT, but in fact, some of the customers who is working for laser welding application were already started to integrate SSOCT. Mainly it's in Japan, but in the future, this kind of the technical trend, we believe it will be happen in Europe and also other regions. Because I know at the moment, the laser welding monitoring application doesn't need kind of the higher performance. Maybe they are satisfied the performance of the spectral domain OCT at the moment, but the technology is improving day by day, and this kind of the trend will be changed very quickly now. In the future, like a medical application and the industrial inline application, so maybe laser welding monitoring application also needs higher performance and a higher performance. So Santec already has the experience to integrate SSOCT engine because we are pioneer of the swept-source. We started this business from 2003. We have knowledge and experience to integrate our OCT technology to our customers' system. So for example, this is the OCT system. So this is the scanner and the interferometer and the measurement test system and the laser. So the laser is key device. We are leading company of this laser swept source. So in the future, I believe, I'm confident. So Santec will be the best partner for laser welding monitoring application in near future, in very near future.
OCT has been very used in the medical market.
Yep.
When it comes to retina display, when it comes to in vivo imaging,
Yes.
doctors are already using OCT systems. Even new technologies are making OCT smaller,
Yes.
more affordable, and has gone through many FDA approvals for many different
Yep.
applications. You are coming saying that OCT is key also for the industrial market.
Right.
And you are talking now about speed, speed, speed. It's about how fast you
Right.
can process. We are talking about a technology which normally has an accuracy maybe 10 microns, maybe 1 micron with some image processing. This is key. Fast, 1 micron resolution, welding. That's your market, right? We are talking about laser welding.
Yes.
Could you tell us if EPIC was to connect you with partners, customers, or suppliers, who would be the key companies you would be interested in talking to?
For laser welding.
Yes.
Actually, there are some big company for the laser welding, like Trump, and some other the laser welding company, Panasonic, and so many companies. They are interested in our technology, and we started that discussion, detailed discussion, to integrate this technology to this laser head. So I cannot say that the specific customer, but now they are interested in.
That's the beautiful part of my job. First of all, EPIC members trust me with knowledge. They tell me things that are confidential. Second, companies like Trump are members of EPIC. My job is to find a way in which Santec can do business with Trump for using OCT in laser welding. For us, for EPIC, it's very important to connect with the Japanese companies. Japan is a very important country in photonics. Think about Fujikura, Furukawa, Hamamatsu, Fujitsu, Sumitomo. We're talking about some of the biggest enablers of mass production with photonics in the world. We try to connect with them, we try to solve the bottlenecks, and for us, having Santec and also Hamamatsu as members of EPIC help us with this particular challenge. We want to create the World Laser Association. We want every company in the world active in lasers to use us to find which companies can be the potential suppliers, customers, and partners. One of the things that impressed me the most about Santec is that you are bringing all the different approaches. And one of them, which I found very interesting, was the market of biology, and in particular, the market of food and beverage. You have here the test of an orange. Would you tell us, in particular in the market of food, what is the products and the services that Santec wants to deploy?
So actually, we are expanding that OCT technology to the biology and some other application. So the kind of the monitoring, especially invasive and in destructive monitoring technique, is important to develop. For example, the drug and the quality of the food, everything. It's important for kind of the monitoring application. So we cannot. So there are many various applications. That's why we cannot say the specific application. But now it's expanding and expanding.
EPIC is active in all the markets enabled by Santec. We have, of course, technologies in silicon, especially in silicon photonics. Silicon photonics is going to revolutionize the world not only of data centers for datacom telecom, but also we are talking about miniaturized sensors. But we do need wafer level testing. We do need the inspection. Here we are talking about very small resolution. Santec is using different approaches, OCT being one of them, to find solutions for this high-speed wafer level inspection. Another interesting market for us is the market of molding. We have lots of companies who need to make molds for the packaging of photonic devices. These molds not need to be inspected because in some cases they will be deployed at niche markets we are talking about markets like space, we are talking about markets like the agricultural market. We need to find ways in which we connect those markets. And finally, the liquid crystal market, the consumer electronic market. Right now, we are in the era of photonics enabling the consumer electronics market. We are seeing for the first time the use of pixels, the use of lenses, freeform optics in mobile phones. This is going to be, in my opinion, the biggest breakthrough in photonics, and you are playing a big role there. Thank you very much for your time. Thank you for the explanation.
Thank you very much.
And most important, thank you for being a member of EPIC.